Satyabama Institute of Science and Technology.
Good day, everyone. My name is Dr. Michael Raul Suse. I am from the Department of Chemical Engineering at Satyabama Institute of Science and Technology. I am here to present the E module for the subject Chemical Reaction Engineering. Now, the first module deals with stoichiometry, the chemistry of chemical reactions. Now, as you all know, in chemical engineering, various subjects are interrelated to each other. Now we have most of you have studied the subject called as stoichiometry mostly in the second year, which normally all the universities do. Now CRE is an integral part, or CRE calculation has an integral base from which is derived from the subject of stoichiometry. Now we are here to see the relationship or the terminologies in stoichiometry which will be used in chemical reaction engineering. The first concept, which is very essential for any calculation in chemical reaction engineering, is derived from two basic subjects. One is physics, the other one is chemistry. Now from physics we have something called as mass, which is generated because of gravity, and from chemistry we have something called as moles. Now both are interrelated. Why? Because in industry, whenever you do a purchase, whenever reactants is procured, it is in terms of mass. Okay, and when reaction occurs, it does not care about how much mass you have put in the reaction. It all depends on how many atoms are there, how many atoms will react with the other atom of other reactant. So that's how a reaction will proceed. For the entire working of chemical reaction, we need to understand two concepts. One is mass and the other one is moles. And even in moles, we have like moles and molar mass. Okay, so mass, as I said earlier, it's basically because of any molecules being pulled by Earth's gravitational force, that is mass. The other one is mole. What is mole? It is basically defined by an Italian scientist, Avogadro, in his Avogadro number, which is the mass of 6.2022 into 10 to the power 23 atoms or ions. Okay, so that is moles. Now we have something called as molar mass, which is basically the number of substance, grams per molar gram, or weight by moles. So that is basically number of moles. Okay, so with this concept we have to enter in a reaction engineering calculation. In reaction engineering calculation, we have a reactant on the left hand side, we have a product on the right hand side, and in this reactant and product there are basically three important terminologies which is required. One is mass, the other one is coefficient, the other one is stoichiometric ratio. Now in reaction calculation, we normally do not use the term mass, we use the term moles. So 1 mole of a substance reacts with the 1 mole of other substance. So that's how a calculation is basically come into being. Okay, let me explain this concept with an example. Now let's say this is a combustion reaction where methane is burned with oxygen. We have carbon dioxide and water molecules being brought up. Now this is the base of any combustion reaction, where any material, when you are burning with oxygen, it produces carbon dioxide and oxygen. Now here we have one atom of oxygen and it is reacting to form 1 mole of CO2 and 1 mole of H2O. Now this is the base idea. So this is the base idea. Now this is it. It's not in the complete format. So what we have to do is, in any chemical, we have to balance out the reaction. Now in the left hand side we have one carbon atom. In the right hand side we have one carbon atom. In the left hand side we have 4 hydrogen atom. On the right hand side we have 2 hydrogen atoms. So first what we do is we balance out the water in the product side. We give it 2. So that's how hydrogen molecules can be balanced out. Now the third component is the oxygen. On the left hand side we have 2. On the right hand side we have 2 in the carbon dioxide, and in the balanced out format we have 2 oxygen in the water molecules. So we have to balance out the one which is present in the reactant. So if you put the stoichiometric coefficient as 2, the reaction will be balanced out. Now even if this is the overview of how your reaction will be, this is the finalized version of the reactant, in which 1 mole of methane will react with 2 mole of oxygen to form 1 mole of carbon dioxide and 2 mole of water. So this is how the reaction is actually taking place in a chemical reaction. Now before we move further with the calculation, we have 2 reactants. So one will be a limiting reactant, the other will be a excess reactant. Now the one historical event is this concept of limiting reactant is what gave rise to the subject of chemical engineering. If you see the book of K.V. Narayan, in the book this concept is explained phenomenally in the introduction section. So we have one limiting reactant and we have one excess reactant. Limiting reactant are the one which are wholly consumed. Excess reactants are the one which you will be supplying in excess. Now in the previous example, methane is there and oxygen is there. So in this reaction, combustion reaction, we need maximum amount of energy from this reaction. So what we normally do is we supply oxygen in excess in the form of supplying air, theoretical air. So when we supply air, we are supplying more amount of oxygen. Now because of this, there is more oxygen available and the chances of methane getting burned out is more. So that's how limiting reactant and excess reactants are basically defined. Next, we have two concepts. We have seen what is mass, moles, we have seen a reaction. Now once product is formed, there are two ways of defining a product. One, we can either define the product as yield or we can define in terms of conversion. Now what is yield and what is conversion? It's a very similar concept with minute changes. Okay. Now yield is how much amount of product is formed. Now here percentage yield is actual yield by theoretical yield. Now what is actual yield? On paper we have stoichiometric reaction in its stoichiometric format. We'll get some particular yield. So for 10 moles of methane I am providing, what should be the desired amount of carbon dioxide and water being produced. So that's on paper, but in actuality something else will be formed. So that when you calculate that part, that is referred to as yield. Now what is conversion? We have supplied some amount of methane. Now when you define in terms of reactant the amount of substance provided, so when you convert that into product, so the relationship between your product and reactant, so that is something called as conversion. Now this is the term which I discussed earlier. One is theoretical yield, which is on paper, actual yield, which we get during the experiment. These are some of the basic concepts which CRE gets from, or chemical reaction engineering gets from, stoichiometry. Now the application of this particular subject or this particular calculation is anywhere where we see reaction. Now in food science we see calculation, in industrial chemistry, almost all the chemical industry, process industry, one or the other reaction is taking place where we have to apply this concept. Then we have environmental science, mostly in terms of combustion reaction or in terms of water treatment or other wherein other pollutants are getting formed. So all in such cases, all in such fields, we will need the use of stoichiometric ideas. Thank you very much.